How does remote I/O work in a real industrial system? Start with one mental picture. Energy or information enters. The equipment changes it in a controlled way, and a measurable result leaves. We will follow that path and identify what can prevent it from working. The essential working parts are field devices, remote input and output modules, a network adapter, industrial Ethernet or field bus, and the central PLC. Each part has one responsibility. Keeping those responsibilities separate makes the system easier to understand, test, and troubleshoot without confusing a displayed command with the physical condition in the field. Sensors land on nearby remote input channels, and actuators land on remote outputs. The adapter packages channel data for the controller network. The PLC reads inputs, executes logic, and sends output data back through the same station. Watch the direction carefully. The next action depends on the previous action completing correctly. Exact settings, fail actions, and timing remain specific to the approved plant design. Remote I/O moves the termination point, not the control responsibility. The PLC scan still depends on network update time, adapter health, channel configuration, and the defined behavior when communication is lost. This hidden relationship is the key to understanding why a normal-looking display can coexist with a field problem. Quick check. What is the main wiring advantage of remote I/O? The best answer is, field cables terminate near the equipment, reducing long individual runs to the central cabinet. The question separates the system's main mechanism from nearby equipment that may only display, supervise, or support the action. Network loss, duplicate addressing, failed power, module mismatch, and channel faults can make many signals disappear together. Diagnostics should separate station-level communication faults from individual channel faults. A safe diagnosis compares command, feedback, process response, and local condition instead of trusting one screen or one measurement. Verification should follow the complete path from the initiating signal to the physical result and back through feedback. Record the as-found condition, use approved test points, restore every bypass and isolation, and confirm normal operation before returning the system to service. Remote I/O places signal conversion near the field and exchanges organized input and output data with a central controller. Remember the direction of energy or information, the hidden conversion, and the feedback that proves the result. Before field work, follow the plant SOP, PTW, isolation, depressurization, venting, draining, PP, LODO, approved test procedure, and supervisor instructions.